Hi, it's Bruce again. Welcome to my Colorado Rocky Mountain lab. And today, what I'm looking at is a Keithley 414S picoammeter. This picoammeter is capable of measuring to within 2% uh, any current from 10 milliamp full scale to 100 picoamps full scale. That would be 100 times 10 to the minus 12 amps. Pretty amazing. Does it in 17 ranges. So you got a lot of current coverage with this unit. Um, I would think it would be particularly useful looking into transistors and biasing and that sort of thing. Uh, I'm sure there's a lot more. This one came out of a biology lab at Temple University at some point in time. Um, it had the cords cut off in the back, and I replaced the cord, and as soon as I plugged it in, I popped the GFI. So I did hook it up to an isolation transformer. It's that big black box back there. Powered it on, and that separated me from the GFI. Everything on it worked just fine. Um, Fuse is intact, no sign of any kind of overheating or damage or anything like that. I've run into this before, and I'm thinking it's similar. It's just that at the time these were made, GFIs were rare, if at all around, and they just didn't look at the possible leakage on the transformer, say, or for filter capacitors or something like that that would draw just a little bit of extra current that the GFI was not expecting. So, knowing that the isolation transformer worked, I picked up a small isolation transformer for the unit, installed it, and at that point the meter came on and essentially responded in every range and in every function. However, even with warm up and everything considered, I found that my ranges were not within tolerance. At least 7 of them were out of tolerance from as much as 2 to 4%. So I wasn't happy with that part of the results, so I decided to go ahead and see what I could do about repairing it. It's a nice looking unit. Got a nice wire stand. It's a heavy cast aluminum case, pretty thick actually. I'd say, maybe 3/32, something like that. We have an output on the back that will output either in voltage, 0 to 1 volt, or 0 to 1 milliamp. You just dial the switch and you have a little calibration for the 1 milliamp. That would allow you to use a chart recorder or an outside meter to read the results. Actually, didn't think about that. Probably could hook this up to my Hewlett Packard. I wonder what that would do. We'll take a look at that. We've got the power on and off switch, meter plus. We have a zero check and then a meter minus, which I'm not going to obviously do that right now. 17 ranges, as I mentioned, and then we have a suppression circuit. And what this suppression circuit does is it allows you to provide a negative current to buck the one that you have coming in, and then the result of the current that's on display then is anything that is above the net of those two currents. If you buck the other one 100%, then it would be just looking at anything above the original. They call it a suppression. You can suppress positive or negatively. You have a range switch of 7 ranges, I believe. Yeah, 7 ranges. And then you have a vernier to fine tune in between the range to give you just precisely the current that you're looking for to buck or suppress. So I ordered what I needed for these 7 ranges that were giving me errors on the range where I was either under or over the full scale by 2 to 4%. A couple of items I did have on hand. I used them. The others I had to order, so I waited some weeks for the orders to come in before I could install them. But we're going to take a look at the results. They're quite pleasing. It was a kind of a difficult thing to work with at points. Most of it is precision resistors, which at the time 1% were considered quite precise and fairly expensive. And especially when you get into the higher resistance range, like 100 megohms up, even today it's quite expensive. I spent some money on this. But I wound up finding the defective ranges. I snipped the resistor out. I took the leads off right close to the resistor body. That left the leads connected to the switch wafers on both ends. And then I was able to connect the new resistor to the wires in between, which made it as easy as I could. However, the range switch here, there are a number of resistors that are on the bottom, and you can see that this suppression switch is in there too. And when you flipped it over and took a look at the bottom, you couldn't see or get to the resistors on here without removing that suppression range switch, which is something I had to do. It's a matter of just removing 2 wires and then taking a nut off underneath this knob, and then you were able to slip the whole thing out the bottom, and that allowed you access to the bottom of the range switch, and then you could continue to work there. That became really crucial in the lowest ranges, the 1 and 0.1 nanoamp range. 0.1 nanoamp being 100 picoamps. Okay, so let's go ahead. I've got the 225 sitting nearby. It's been warming up for at least 24 hours, so we should be fairly stable. I'm going to go ahead and apply 10 milliamps to the 10 milliamp full scale on this meter. Let's go ahead and check the zero just while we're here. Yeah, it didn't move at all, or if it did, it's very, very minor. Let's go ahead and apply 10 milliamps. All right, we got the 10 right on the needle right on the 10. If I look in the reflective mirror, we're right on it. We're right within a hair. Okay, so if we then reduce the current from the source here to the next range, so now we're going from 10 to 1 milliamp, and we see that the needle has gone down the dial to the 1 down on this end. It's because we're on the 10 range. If I go to the 3 milliamp range, we see that we're on the lower range here. We come up to a 1. Could go to a 2 or 3. Then we go to the 1 milliamp range and we come up full scale. That is excellent. So then we'll go down another. Okay, we are now at 100 microamps. So 100 microamps would be 0.1 milliamp. If I go to the 3 scale, we rise up to 1. This would be 0.3, so over here is 0.1, that's 100 microamps. Or I get just slightly over by a hair. It's very small. over the 10 in this range. So we're 100 microamps coming in. Let's go ahead and reduce the range again. Okay, now we've got 10 microamps coming in. We've dropped down to the 1. We go to the 0.03 milliamp range, would be 30 microamps. 30 microamp range. We are feeding in 10 microamps, so we're at 1. If I go to the 10, we see that we have risen to 100%, and that's with 0.0 microamps, so 10 microamps. Go ahead and we'll reduce our range again. We are now at the 1 microamp range. So we're on 1 here, we're on the 10 scale. Going to the 3 microamp scale, we rise to 1. Going to the 1 microamp scale, we go to the 100%. Okay. Let us drop down to the 100 nanoamp scale. Okay, we're reading 0.1 microamps, that'd be 100 nanoamps. Going to the 0.3, we come up to 1. Going to the 0.1, we go to 100% here on the top. So there's 100 nanoamps, and every one of the little lines in between would be 1 nanoamp. We'll go ahead and reduce ourselves once more here. This would be the 10 nanoamp scale. We are reading it on the 100 nanoamp range, so we got 1. If I go to the 30 nanoamp range, we rise to 1. And if I go to the 10 nanoamp range, we come up to full scale. That's 1. So we've got 10 nanoamps here, is what I'm saying. We will reduce from 1 to 0, and then we'll come up from 0 to 1. So now we're reading 1.0 nanoamps. So we're feeding in 1 nanoamp. And here we're reading a 1 on the scale of 1 to 10. We're on the 10 nanoamp range. We're going to go to the 3 nanoamp range. We see that we've risen to 1 on the 3 nanoamp range, so we're reading 1 nanoamp. And if I go to the 1 nanoamp range, we're at 100%. So far, excellent. Okay, so now I reduce my 1 to a 0, and we come up to a 0.1. This is 1 nanoamp range, we're reading 1, so we're reading really 0.1 nanoamps. Going to the 0.3 range, we come up to 1 out of 0.3 would be 0.1. A little light there, but if I go to 0.1, just about 100. So that would be 100 picoamps full scale, and if I get near the wire or anything like that, it's sensitive, so little tough to get a really stable reading here, but there we go. Thing is working beautifully. It would be quite possible to suppress this by applying my suppression here, turning that on and then suppressing it to 0. I can now bring my sensitivity back, and if I remove my suppression, we're going to see a dramatic swing in the meter. So we can go back up to the 100%, or I can take it and take her down to 0, and in which case anything that shows up on this meter at this point above that is going to be due to additional signal. So I've suppressed 100 picoamps, and any other current that comes through is going to be additional to it. That's sort of the suppression idea. I will go ahead and remove that, and we come back up to the 100%. Okay. Okay, we've got the 225 connected up. We're at the top milliamp scale. We're reading 10 milliamps in, and we have got a full scale reading of 10 on the 10 milliamp scale. Let us cut that down. Okay, we are now reading 1 milliamp, and on the 10 scale we are setting on the 1 on the top. If we go to 3 milliamp scale, we pop up to 1 on the lower scale there. And if we go to the 1 milliamp scale, we go to 100% full scale, and we get a reading of 1. Okay, let's go change our range down again. We are now reading 100 microamps. And we are on the 1 milliamp scale. We are getting 0.1 on the top. We're getting 1 on the top scale of 10, which would be 0.1 for a 1 milliamp reading. And let's go to the 0.3. We see on the lower scale we popped up to 1. If we go to 0.1, we see that we have popped up to 100% full scale. And that would give us a reading of 0.1 milliamperes, which would be 100 microamperes on this scale. Once again, we reduce our scale for the, we go to the next lowest decade for the current source. We now have 10 microamps. We are on the 100 microamp scale. We are getting 10% of that scale, so we are getting 10 microamps out of 100. If I go to the 30 microamp scale, I'm reading 10 on the lower scale. And if I go to the this would be 10 microamp scale, I am reading slightly over, actually, hair over the 100% scale, but looks like 10.1 maybe. Okay, then we go to the next lowest range. We are on the 10 microamp scale. We are feeding in 1 microamp. We are reading 1/10 of scale, which would be 1 of 10 microamps. We're getting 1 microamp out of there. That's good. Going to the 3 microamp scale, we're getting a reading of 1. Going to the 1 microamp scale, we're getting perfect reading of 10, or 100% of scale. I don't know if we can get that clear. We're trying. Okay, reducing the scale once again. We are now reading 100 nanoamps. We are on the 1 microamp scale. So we're reading 1/10 of scale, which would be 1/10 of 1 microamp. That'd be 0.1 microamps. Okay. Going to the 0.3 microamp scale, we're reading 0.1. And going to the 0.1 microamp scale, we're getting 100% full scale. Reducing the range again. We are now putting in 10 nanoamps. And we are on the 100 nanoamp scale. 1/10 of that would be 10 nanoamps. Going to the 30 nanoamp scale, we're getting on the lower, I'm getting 10 nanoamps showing. And going to the full scale 10 nanoamp, we are getting 100%, that's 10 nanoamps. Okay, reducing our scale to 1 nanoamp. We're on the 10 nanoamp scale. So we're getting 1/10 of scale, it'd be 1 nanoamp, which is what we're putting in. Going to 3 nanoamp scale, we're getting on the lower scale a reading of 1. Going to the 1 nanoamp scale, we're getting a 100% reading. within a hair. Looks like we're a hair low, maybe like 99.9 or something like that. Hard to say. All right, we've got 0.1 nanoamps coming in. We're on the 1 nanoamp scale. We got 1/10 of the scale. That's 0.1. If we go to 0.3, on the lower scale, we rise up to about 1. Looks like we're just a little shy of it, but we're right at about 1. And if I go to the 0.1 scale, we are 100%. A little bobbly, but it's right there. Okay, let's take her back up again so we're not likely to damage anything in transient. Okay, so we're giving a little test here. We're using the picoammeter in a circuit to determine resistance of a high value resistor that's in red down there. We're feeding in 100 volts from that Fluke 343A. We are confirming the 100 volts on the Hewlett-Packard here. Okay, so we're doing a little experiment here. We're determining the resistance of that high resistance 1 gig red resistor that's laying on the mat there. We're feeding 100 volts in from that Fluke that's up above. We are measuring the 100 volts off of this Hewlett-Packard, where we will make sure that we have it adjusted appropriate. Okay, there's 100 volts. And we have suppressed 0.1 microamperes of current. And after that suppression, we saw that as we changed our gain and went lower or higher in gain, we saw that we were going negative, so I had to change my polarity on the meter to negative. And what we see is a reading of about 0.54 nanoamps. 0.54 nanoamps. So that would be 0.54 nanoamps to the negative of a perfect 0.1 microamp. So we'll do the math on that, and then we'll see where we wind up. Okay, looking at the formula up here, I see that I've got 0.1 microamps minus 0.54 times 10 to the minus 9th. So that'd be 0.54 nanoamps. And I got 9.946 times 10 to the minus 8th amperes. And that gives us 1 gig. So it's 1 gig, 5,399,318 ohms. That, compared to a perfect 1 gig resistor, gives us about 0.54% error. Now, what's interesting about that is I've measured this resistor 2 other ways, and as it states on the side of the resistor, and I don't know if you can see it there, I hope you can, it's 0.5%. So I've confirmed the 0.5% maybe actually went to 0.54. So there we go. We've used this already to verify a 1 gig resistor. I couldn't do that with my Hewlett-Packard. I have done it with, I have used this resistance bridge, this ESI 230B. And I also used a little box that I glommed together, and we'll talk about that. I discovered in the process of working with these resistors that I didn't have anything that could read resistance higher than about 10 meg. So I came up with this little box, and that'll be the topic of another video. But other than that, I appreciate that you listened and watched if you've gotten this far. It's a beautiful little picoammeter. I'm happy to have it. It has cost me more money than I expected, but we're somewhere in the range of about $100 now invested, and that's not bad. Okay, see you next time. Bye.